please introduce yourself, introduce Trasna, and also start your presentation.
Thank you, Anand, to introduce me and to invite me in this great platform. So I think you can see my screen. I would just like to share it. Yeah, I think you can all see my screen.
Yeah.
So today will be, I was just listening since from the morning. It was very interesting and very engrossed presentations all we are giving. So today will be talking about this technology trend of Trasna, intelligent connectivity and security initiatives, and some synergy between AI, IoT, and 5G. And we'll try to give a brief roadmap and some live use cases to demonstrate what Trasna is doing. So before this session, I think everyone was witnessing and seeing the videos of Trasna. I'll be requesting all of you to go to that strands of trasna.io on this next metaverse platform, and you will get plenty of offers to have some innovations and research products. So what about Trasna? Trasna is a focused on technology leadership, and it is mainly combines the innovation in semiconductor design, secure software, edge computing, AI, and blockchain. So I am talking about many buzzwords, but all buzzwords you can integrate these buzzwords with the 5G and connectivity streams. At the same time, we are talking about IoT and connected devices. So we are in the connected world. So Trasna is also the future of the IoT. So before going into the deep dive of the presentations, I will give you the overview of this talk today. We'll provide some snaps of global tech trends, of course, on connectivity till 2030, and then the missions of Trasna or Trasna's objective. Then I'll be presenting some functional use cases, and especially the connectivity and monitoring in terms of predictive maintenance and remote monitoring. And then we will discuss briefly about security aspects, what Trasna is doing for the AI and blockchain, and the takeaway and some live cases. So before we are going to deep dive, I'll be introducing two snaps on my slides. One is basically called massive machine type communication in 5G service industry. And another is URLCC. I think you can see the URLCC, that's ultra reliable, some kind of latency network. So both these technologies and both these terms are giving us snaps that you can see that MMTC and URLCC right now in 2020 and 2024, the density of connections are much more lower. And if you are going to this, then you are seeing the all overlapping structure here. So there is one navigation and one migration from 5G plus to 5G plus plus, and there is 6G also, which is coming in the down line at 2028 to 2030. So you can see the connection density and the ultra reliable low latency communications are much more prominent and becoming prominent in more the years to come. So if this is a statistical and global snapshot where connectivity and trends are lying right now, so we can go together what Trasna is thinking. Trasna's mission is all things sensed, all things connected, and all things intelligent. What does it mean? It means that we want to sense everything, including temperature, space, touch, sense of smell, hearing, and vision. And we also want to be connected. And in connections, we are talking about ubiquitous connections, wide connections, multiple and deep connections. All these things should be intelligent. So that means that only connection and only sensing will not make any kind of inference and decisions. At the same time, we need to be intelligent, we need to be adaptive. So we are combining AI into it. So if you see the paradigms, you can see the broadband, you can see the data centers, you can see the cloud computing, big data, IoT, and AI. So all these terms I told you in the very first slides that I'll be putting lots and lots of buzzwords, but these buzzwords are all the integrated part of the 5G connectivity and 5G ecosystems. What Trasna is thinking about this mission. So broadly going for the connectivity intelligence, because as I told you that one of the mission is the AI, and as a pure and innovative researchers of AI for last 29 years, so I will say some kind of potential directions of three main categories. You can see my left hand side that there is narrow AI or single task intelligence, which at the same time we are now 2020-2024. Then there is a strong AI cognition and inference, where you can see the applications are going and still going on, like autonomous driving, intelligent diagnosis, and smart assistant. And then super AI. This is another thing to come, which will be giving a more awareness and consciousness of the brain or of the mind. So if you are dividing the AI task in connectivity in these three scenarios, the things are very clear that we are into this domain right now of strong AI and cognition and inference. So you can see all these kind of use cases which we are going to foster in our real applications or industrial applications. So if you are going for the connectivity scenario, things are very much prominent here. So if you are talking about connections, if you are talking about sensing and hearing and inferring or making a decisions, you need to have a couple of components in your bag. One is, of course, the remote monitoring, which you can by the remote monitoring, which you can investigate trends and patterns. And then you can see that you can differentiate, you can classify everything on communication and everything on the fly, that what is good and what is bad. And to infer all these things, you require some kind of learning. So of course this gives a sense that we are talking about something on the maintenance part, that if you are having a smart connections or smart connectivity scenario with AI and connected devices, then you can have the remote monitoring. You can see the you can see and classify the trends and patterns. You can learn what is good and what is bad, and of course you can combine all these things with your intelligence. So fact is that if you are going deep dive into this remote monitoring systems, then you can see that suppose there is a part of machineries, and these machineries are well connected with some sensors, actuators, and IoT devices, flip-flops, gates, and everything. So if you can see, if there is some process is faulty between all these connections, then you can have a kind of alert in your mobile edge device. So I'm showing the snaps because if there is some kind of connection, some kind of communication, then you can always synchronize your mobile edge devices with these all scenarios, and you can get a kind of snap alert that is if there is a problem in your systems. So this thing shows that we are having combining some kind of contextual data. Contextual data means that you are trying to gather the information from the connected systems and try to synthesize that connected data to your mobile edge devices and to your communication devices, so that you can get a kind of alert about your system, what is happening inside, and how you are going to shoot the trouble. So fact is that at the same time, you can also analyze and classify your decisions, your inferences on the fly. On the fly means that if you are having a communication device, you can detect from your communication device that your IoT or edge devices are getting faulty, or it is becoming very much healthy. So I mean to say that you can have the possibilities that you have the data analysis on fly. And exactly Trasna is offering these kind of solutions which are quite innovative. But the question is that I am talking about data science, I am talking about AI and analytics and sensing and learning, but I didn't talk about the security. Because the problem is that whenever we are trying to expose our inferences, our decisions, we are trying to also expose our data. At the same time, in the morning session, someone talking about the Google mobility. Of course, we have been offered by the great services by Google, but at the same time, our data will be compromised. So to make this kind of thing not to happen, we at Trasna, we are having some kind of secure elements, and we are trying to combine three things together. One thing is, of course, we are very much aware that we are connecting different machines. We are also very much aware that only hardware security should not be too much optimistic for the end users, because there might be leakage. So we are offering a kind of blockchain. But don't misnomers, and don't to be ambiguous with blockchain term, because we are using blockchain in terms of storage, validation, and authentication, not kind of cryptocurrency type of aspects. So we are trying to prove or provide blockchain solutions to prevent anti-counterfeiting for original equipment manufacturing, so that if your IoT devices have been stolen, if your IoT devices have been replaced, then with our solutions, with these kind of solutions, you can always authenticate and validate that there is no problem of stealing and there is no problem of replacement. So with this kind of sensor data transaction and stored in blockchain, Trasna is also trying to integrate the security between operators. So what does it mean? Basically, we are in the communication scenario, and in the security edge protection proxy, there is a proxy term called SEPP, and it is of course very much prominent for the 3GPP services, which is third generation partnership project. And for any kind of mobile protocol, these 3GPP are responsible. So Trasna's goal is that we are trying to make this kind of protocol to be detected autonomously by the systems, by your connected devices. So you don't have to do anything separately, but your automatic programming, automatic AI algorithms can do it. So we are trying to produce some kind of deep neural network, which should be a tiny machine learning architecture, and it should be embedded on the chip. And at the same time, this kind of algorithm, this kind of software application can just give you certain kind of 3GPP and security edge protection proxy services at the edge. So for the time being, we are also trying to produce some kind of API. Those APIs can also detect the attacks, can also detect the malicious code, and also can go to the PLMN. PLMN means that public land mobile network systems, to consolidate the trust, because we are talking about the connected paradigms, we are talking about the connected environment. If you are not establish the trust between the connected devices and the users, then everything should be baseless. So to perform that thing, we are trying to produce AI algorithms for giving kind of security API generations. But remember that everything should be on the chip. So of course, we have to take care of many things like latency, like scalability, like security, and the network virtualizations, and at the same time, some kind of building of some kind of private network with private blockchains. So if you are talking about 5G network security situational awareness for our connected device, we have three stuff in our slips. One is the security management platform, another is the security analysis platform, and is the security control platform. Three things are, I mean, the second and the third components are partly from the data science and analytics, but the first thing, of course, is completely dependent how you are going to produce these smart contracts, how you are going to produce these certificates, how you are going to commission those certificates to the end users. And of course, here we are also combining identity management of IoT device at the same time. So all this, combining all these things, if you are thinking of this, then probably network intelligent element security, which Trasna is futuristic with their vision to improvise all these secure intelligent element more dynamic. So I would like to mention three security elements as a must component or must plus for future networks. One is of course the MME, that's mobile management entity, which is, I told you that it's related to the identity management. Also the ENB, that's Evolve Node B, is another kind of very much 3GPP protocol. And another is the packet data network gateway, which is PGW, which are completely responsible for all the features of network intelligent element security. So Trasna's futuristic vision is that to produce certain kind of machine learning and AI algorithms to make more secure intelligent elements. So for these reasons, we have some challenges and solutions at the same time, because the paths are not very smooth. First challenge is that the connectivity and the sensor data. Yeah.
Sorry, we need to conclude in 1-2 minutes maximum.
Yeah, sure. So we have this kind of challenges, that a large number of sensors data, and we are trying to investigate the problem of anti-counterfeiting. And I'll be showing a very brief thing so that you can see that what is happening here. I guess it will be workable. So I'll be showing you a very first kind of wireframe, where you can see that how we can get a welcome smart network, water network for digital twin. So we are trying to leverage these kind of things for the mobile edge devices. And for mobile applications, you are having a water network, and the smart water network, you can see the overview that how the water network should be flowing into your locality or into your domestic services. And at the same time, just give me one sec so that I can show you all the stuff in the wireframe. So at the same time, you see the different sensors and the pumps are associated with it, and all are connected, and they are communicating with each other. And once they will be establishing the communication, then you can find out that if there is a problem here. So I can show you here. Yes. So you can see that if there is a problem or there is a shoot of troubles, that we can produce a kind of twins using AI technology to troubleshoot this thing. So you can see, if you are doing a data analysis and data science report, you can always find a kind of machine status, that what kind of pumps and what kind of sensors are not working and what are much more functional. That's from my side, because we don't have much time. You are cordially welcome if you are having any questions, and catch up with trasna.io. We are always offering a bunch of innovative solutions for you to come. Thank
Thank
you
you
so
so
much.
much. Thank you, Soumya. Thank you so much for this presentation and sharing with us your efforts and perspective, Trasna efforts and perspective for the future. Just when we speak about connectivity and cellular connectivity, we speak also about GSMA. They are the standard organization really driving. Do you think that for blockchain you need to contact and to work on the GSMA to put such kind of approach or standard in the market, or it's really agnostic connectivity, means you don't need, you don't interfere with the GSMA standards, and you can make it, without any standard from the GSMA?
Yeah, that's a good question. We are not at this present sort of time. We are independent, so we will not interfere with their standards. We'll be respecting their standard at the same time, because we are talking about the private networking and we are talking about the private blockchain. So in terms of developing the private blockchain, we don't require to touch their standards and to modify their standards. But at the same time, if you are talking about the billions and billions of IoT devices, as I shown in the density connections like URLCC or MU-MMRL, so this kind of density if occurs, then of course we need to respect their privatizations and network virtualization schemes of GSMA. And we are quite aware of the protocols, what they are talking about and what kind of standardization they are offering.
Thank you. For the time being, no interference, but it may come in the future. And
yes.
Thank you. The other question, Soumya, is about your vision. You mentioned what you are doing with the Trasna in this area, but what is your vision? Means the big trend is of global IoT M2M connectivity. What you see in the future for such kind of IoT connectivity?
There are three pillars to say in terms of IoT roadmap, or in the vision of huge massive world of IoT business. At the same time, first pillar is of course the connected environment should be secured. And whenever we are talking about security, it's not the cloud security. We are talking about security on the edge, security on the hardware. So first confirmation, first decision from Trasna's initiatives for the innovation, that's the blockchain on chip. Because we are trying to fabricate and we're trying to design the smart design on the blockchain on the chip, so that we are trying to maintain the latency. We are trying to offer good scalable solutions. We are trying to make energy consumption as in the context of the narrowband IoT. This is the first pillar. Second pillar is that if that secured element should be intelligent, because we have to produce some hardware to show AI capability for security, not like cloud applications. And third, of course, the integration of the AI and the security at the same time, because we need to standardize, we need to market ourselves, we need to position ourselves that everything should be on chip, nothing should be on the cloud. And whatever you offer in the chip, that should not make you much more, you can say, heavy task to maintain or to give you the most and flexible cost benefits. That's the three pillars for the innovations we are talking about at Rasna, and we are quite deterministic that we can offer it very soon.
Thank you so much for sharing all this information with us, Dr. Sumya Banerjee. And anything to add before introducing our next speaker?
No.
Thank you.
Thank you.
I hope to see you in our roundtable
Sure.
at the end of the day.
Sure. Thank you.
Next